This math problem that was left on Facebook for me this morning, there are an infinite number of solutions, but I had to go ahead and make some assumptions. First of all, we've got the numbers. Oh shoot, new pen. Sorry the video's so dark. Suppose we have the numbers A, B, and C, X, Y, and Z. Okay, such that A, B. These are all of these have a common prime factor. Okay, so here for that condition, I'm going to force that to be the common factor. Call it. I'm going to call it gamma 3. Okay, that's so all 6 of these numbers have to have a common factor of 3. Okay, and went ahead to make some further assumptions because they were not illegalized in the problem. The problem is find A, B, C, X, Y, and Z such that A raised X plus B raised Y is equal to C raised to the Z power. Okay? This is Pythagorean in nature. Looks like Pythagorean theorem, except all 3 terms are variable and they have variable exponents. We're going to unvariate some of those because it wasn't restricted in the problem as it was given to me, as it was given to us. So assuming this, I went ahead to make some observations that A has to be greater than or equal to B in order for this to be a real number. Okay, and then Z has to be greater than A, which has to be greater than B. Okay, then I went ahead and said, oh, or equal to, greater than or equal to, yeah, okay. Then I went ahead and said let A equal B, because it wasn't illegal, and let go ahead and make the let statement. Let X equal Y. Okay, so we're going to hold those things constant, or semi-constant there. Those are conditions I set up. Okay, then I'm going to go ahead and assign Z. I'm going to say let Z, I'm going to give that a definite value, let Z equal 3, okay? I'm going to let Z equal 3. And so I want to point out that the 3 is greater than 2, and it also has a prime factor of 3. Alright, so let's get on with the problem. The problem then becomes, we can rewrite the original, okay? I'm going to leave those up there. Rewrite the original here. This AX plus BY is equal to CZ. I'm going to rewrite the problem, adopting all of my requirements. And so I'm going to get, excuse me here, I'm going to get b to the y is equal to, since b is equal to a and x is equal to y, then I get ax squared plus ax squared is equal to c cubed. Okay, so then I can say I get 2ax is equal to c cubed. We're going to go ahead and solve this for c. Okay, so I'm going to get c is equal to the cube root of 2 a raised to the x power. Okay. Oh yeah, I had one more condition there. I also assigned let x equal 6, the number 6. Okay, so the number 6, I'll go ahead and point out, is greater than 2 and also has a prime factor of 3. Okay, so here we are. We can go ahead and further rewrite this as c is equal to cube root of 2a raised to the 6th power. Okay, so this is a mathematical creature that looks like this. Okay, this y-axis, x-axis, and it looks something like this. Okay, numbers are going to get huge, but there is a solution here. We'll go ahead and plug and chug values for a. We'll let a go to infinity. Actually, we'll go ahead and set a domain. We'll say the domain for a here is 2 to positive infinity. Okay, that's the domain. The inputs for a, and we want to find the a that gives us back a value for c that has a prime factor of 3. All right, so we get the first solution for that when a is equal to 390. When a, okay, this is the first one. When a is equal to 390, then c is equal to 191,634. Okay, so let me go back and erase. Okay, so what we have here, the problem, the 3 variables, x, y, and z, and such that those 3 have a common prime factor of 3, and that x, y, and z are greater than 2. I went ahead and made some assumptions. I observed that a has to be greater than or equal to b, z has to be greater than or equal to a, greater than or equal to b. So I went ahead, and as soon as it wasn't illegal, I said, well, let's just let a equal b and let x equal y. Then I went ahead and assigned values that met the original requirements. I let z equal 3, which meets the requirements. Z is greater than 2. It also has a prime factor of 3. Then I let x equal 6, which is greater than 2, and has a prime factor of 3. I went ahead and made the replacements in the original problem, and that reduced to c equals 2a raised, or the cube root of the quantity 2a raised 6. I went ahead and started entering values in this function of a until I got back an answer for c that was a whole number, an integer. Oh yeah, that was another one. It had to be an integer, and it has to have a prime factor of 3. So write down this list of this is the first solution there in the number line. And then if you just start plugging in values for a, we get an input value for a of 390. Okay, we get a b we said was equal to a, so that's also 390. C, we actually got back functionalized c there, 191,634. 1634. Okay, and I got x equals y equals z equals 6. Did I get that right? Yeah, no, x equals y, and those two are equal to 6 by assignment. And then also by assignment z equals 3. So this is all 6, a, b, c, x, and y, and z that meet all the requirements set forth in the problem. Now this would be the first of an infinite number of solutions. The numbers will be huge. If you want to go ahead and dig out a few more of those, they're going to get huge. Anyway, I'm not sure, but I think that's a solution, at least in terms of the validity of my replacements there. It wasn't stated for that to be illegal, so I think that might be a solution. I don't know. your boys down in Texas probably would have solved it if it was that easy by now. So maybe those replacements and let statements were not legal. All right, see you, bye.